Right guys, now what I've done for number 10 over here is I've only focused on number C, because these questions here are pretty average, pretty boring. So this is where maybe things are a bit more interesting. Line of intersection, right? So put the timer on for 4 minutes. Okay, so you know the drill. 4 minutes, 4 marks, 3, 2, 1, let's go. So what do we need to do here? Okay, well, position vector C and D. Well, C and D. CD is equal to OD minus OC, right? Which gives me what? Well, what's OD? Well, OD is 5 negative 6, 11 minus OC 1 negative 2, 5, right? 4 negative 4, 6. Brilliant. So now what's the equation of the line going to be? Well, the way to think about this is, remember, if we got a line L over here, C and D over here, okay, point of intersections over here. So the equation of the line is going to equal, first off, I'm going to have direction vector 4 negative 4 6, right? Now because we just need to find a point on the line here, that's inevitably going to equal 1 negative 2 5, okay, because OC. So what we can then say is, all right, 1 negative 2 5, okay, and therefore we can say, well, look, R2 is equal to 1 plus 4 mu minus 2 minus 4 mu 5 plus 6 mu. R1, what's R1 going to equal? Well, this is R1 from our previous calculations, which I didn't go through before. It's quite easy. So 3 minus 2 mu, negative 1 plus 3 mu, sorry, lambda, 1 minute 48, okay, and 2 minus 5 lambda, right? So now we just need to equate these, right? That's the point of intersection. So if we equate these, what we get then, 3 minus 2 lambda equal to 1 plus 4 mu, negative 1 plus 3 lambda, negative 2 minus 4 mu, 2 minus 5 lambda, 5 plus 6 mu, right? What does that mean? What that means is that 4 mu is going to equal 2 minus 2 lambda. Okay. Now this is going to be our number 1. So using that, we can say, well, okay, if we plug that in, right? If we plug that in, what we get then is negative 1 plus 3 mu is equal to 2. Sorry, minus 2 minus 4 mu, so that's 2 minus 2 lambda. Okay, almost done, 30 seconds. I don't know if I'm going to make it. Negative 1 plus 3 mu is equal to negative 2 minus 2 plus 2 lambda. Right, perfect. And I can therefore say that negative 1 plus 3 mu, 3 lambda, sorry, negative 4 plus 2 lambda, 3 plus 3 lambda is equal to 2 lambda, which means that lambda then is equal to minus 3. Ah, there goes the clock. Alright, well, I failed, but anyways, finishing it off, lambda equals 3, negative 3, sorry. So 4 mu is equal to 2 minus 2, negative root 3. Right. And therefore 4 mu is equal to 8, mu is equal to 2. Alright, so therefore position vector is going to equal 1 plus 4, 2 minus 2 minus 4 times 2, and 5 plus 6 times 2. Okay, 9, negative 10, 17. Okay, so I failed, guys, so I guess I'm going to get a bunch of dislikes for this video, but yeah, that's basically it. You got to find out the different equations, okay, then set up simultaneous equations after you get the vector line, of course, right? And okay, we got that. And you get the position vector when plugging in the values. That's it.